Aloha, Richard Halverson here. This is ICS321 and summer 2021, and we're on video 9, I think, and we're gonna finish up chapter 3 today. So let me share my screen. Okay, let me go back to here, and we are didn't turn my phone on fast enough. We are here. We're going to finish up chapter 3 today, so I'm going to do like section 7, 8, and 9, I think, and I'm also going to probably try to quickly go through this assignment because this fits right into the last section of chapter 3. So if we go to, we ended on section 7 last time. By the way, I just uploaded this. So I just uploaded this. And so those of you that are watching this video, note that this is video number 9 that we're watching right now, and video number 8 is there. So you got to make sure you look at that video also. You should. All right, so so we just finished up 7. So let me just at the end here, let me just to remind where we are. And here we were you know, the beginning of breaking up tables or connecting relations to each other using keys. And so you know, so we had to look at the cardinality of the relationship, and we decide where the foreign key goes, and then there's this thing about naming the foreign key. The foreign key is a link to another table through its primary key. And they recommend, or they said, with an optional prefix. And it turns out that if you, I was doing I was going through this earlier today, and the last one here, let me refresh this. Maybe it'll start over again. Oh, it will start over again. So the naming convention is not that big a deal. The important thing is that the types are the same, and what the definition of what the column actually is. So here, if we have a one-to-many relationship, like a parent can have multiple children, then to implement the relationship, in the child record, you put the primary key of the parent, because a child can, let's say, that's mother. Okay, the primary key of the mother. Let's say it's mother and children. Mother can have many childs or children, but a child can only have one mother. So the foreign key would go into the child table, and that foreign key would be the ID of the mother. All right, so and so here, let's just quickly do this one, and then we can go on to the next section. So this is the last challenge activity. In which table is the foreign key placed? Okay, so we have a campus and university, and so a campus can only a campus is part of a university, and a campus, the minimum number of universities is 1, and the maximum number is 1. So it's exactly 1. And But a university could have 0 campuses, 1 campus, or many campuses. And so the foreign key should go in the many side. So there should be a campus. So in the campus table, there should be the ID of the university. And so so the foreign key should be in the campus table. So let's pick campus table. And the name of the foreign key should be something to do with university ID, okay? And in going through the exercises yesterday, where it seemed like they put the prefix, this prefix on the primary key name. You know, when you're naming a foreign key, it can be confusing. But anyway, the answer here is this: university ID. Because I mean, you know, you could name it anything. You could name it this or this, as far as I'm concerned. This, well, you can name it anything that has university ID at the end. But this is not a suggested way because it's got the ID in there. So this is a field, you know, a column name and a column name. And so that's not the right answer. It's this one. And are nulls allowed in the foreign key column? No, because of this one here. The university ID is the campus has to be a part of one university, exactly one university. So I think the answer is no here. I hope I'm right. All right, let's do the next one. In which table would the foreign key usually be placed? Okay, so an apartment, it looks like has to have exactly 1 mailbox, but a mailbox may not have an apartment number or have 1 apartment number. Is that what is that what that says?
I think so.
Yes. Okay. So the foreign key would be in the. Yes, it doesn't. What is this? Oh. What does it say? In a new table, apartment. I think apartment.
Yeah, I think so.
And what is the name of the new foreign key? Mailbox number.
Yeah.
And are nulls allowed in the foreign key? No, because of the 1 there. No, the minimum on the mailbox side is 1.
Okay.
Right?
Yeah, right.
Uh-oh.
Oh, wait. Table with fewer rows.
Wait, did I? Did my numbers quickly go away, or okay, let's just, so what did I say? Okay, let's just do this over again. Mailbox, apartment number.
Oh, I thought that one.
Oh, okay, well, let's do this again. Okay, let's just do next. In which table would the foreign key usually be placed? Okay, so we have a person with a driver's license number or a driver's license with a person number. I guess okay, so I guess the foreign key should be placed in on the person side. If you look at it from a, you know, sometimes I think studying implementing databases this way only starts to confuse you because you don't know whether you should step back and look at this, you know, from a practical point of view, or try to follow these rules that they tell you. But a person can have 0 or 1 driver's licenses, but a driver's license has to be has to belong to exactly 1 person. So which table should have the foreign key? You know, I know from a practical, well, it's either driver's license or person.
So it says for 1-to-1 relationships, the foreign key is usually placed in the table with fewer rows. So,
Oh, so fewer rows would be this one. The foreign key is placed in the driver's license table.
okay.
Because I mean, right, that's the one with fewer rows. Because
I would think so.
there's more persons than driver's license. So I'm gonna
Right.
say driver's license. And then are we going down the same path we did last time? What is the name of the new foreign key? Person ID.
Yeah.
And are nulls allowed in the foreign key column? I'd say no. And I think last time I said,
Yeah, I think it's no.
no, the minimum on the
person side. Yeah.
One.
I think so.
All right. Oh, wow.
Okay, great.
Let's do the next one. Because yeah, there are different ones. Obviously and it's probably random which one you get first. So, all right. So multiple students take multiple classes. Okay, so there's many. So there should be. It's just what are the foreign keys in the new table? It would in the new the new table would have to be a table that's got the student ID and the course ID. And they're both foreign keys. Oh, so it's this one. See, so to implement this, there would be another table in between here, with whose primary key is a composite of the student ID and the course ID. So that would be and they're also each foreign keys too. So select possible primary keys of the new table.
So that would be the two of them together?
Yeah, but why are, okay, all right, I guess it's those two then, right? Because they're both the same, right?
Yeah, I think so.
Composite of student and a third, no, because a student can only, so for a particular course, yeah, it's only one. A student cannot register for twice for the same course ID. Actually, they can't they? So how about if a student repeats a course?
Oh.
Well, I'm just going to say this, because I don't think they intend to consider that, but let's see, they might intend. Oh, yeah, good. All right. Okay, very good. Well, let's go on to implementing it. Yeah. Thank you. And I'm sure the folks out there watching this at a later time thank us. Okay, so implementing attributes. Attributes can be singular or plural. Each entity instance has at most one singular attribute instance, and each entity instance can have many plural attribute instances. Sure. So in the implement entities step, entities become tables and attributes become columns. And singular attributes remain in the initial table, but plural ones are moved to a new table. And like, for example, so if we think of mothers and children, let's say so let's say you have a mother's table and you want to store the names or the names of the children, or the IDs, let's say, of children. So the children, a child would be a plural attribute. So the new table contains the plural attribute and a foreign key referencing the initial table. So the initial table would be the mothers and the foreign key would be children. the attribute would be like child's name or whatever, ID, and the foreign key in there would be of the mother, the ID of the mother in the mother table. Primary key of the new table is a composite of the plural attribute and the foreign key. So you'd have this child table that's got a child ID, and it's got a second column that's the foreign key, which is the primary key into the mother table of the mother. And the primary key of this table is not only that, oh, it's a composite of the, now why can't it just be the child ID? I guess in this case you are, yeah, okay. So the child ID can perhaps be the order in which the child was born or something. So the primary key of this new table would be the foreign key into the mother table, and then this second column that identifies a child, children of the same mother. Confusing. The new table is dependent on the initial table. Can't have children without mothers. The primary key, cascade, and foreign key restrict rules are specified, which means you can't, if you delete a mother, I guess you delete the mother's children. You can delete a child, but you can't insert a child. I mean, you can't insert a new child without the mother already being in there. All right, and here they give a recommendation for the name of the table. So that the initial table followed by the attribute name. So the name of this table might be mother's children or mother's child's or mother child. All right, so you can go through this. So we have so these are two examples. On this side, we have it where the attributes are actually in the table itself. And the only time you can do that is if you can say that there's a maximum number of instances. And so otherwise, the plural attribute is meals. A flight can have 0 meals, 1 meals, 2 meals, or 3 meals. You see there. That's what they're saying there. And so, but if there's an unlimited number of meals, or if you don't want to state a maximum of the number of meals, then you would pull it out, and there'd be this second table here. The name of the second table is the name of the primary table, and then meal type is the actual attribute name. So we can see what this looks like. So this is a plural attribute with some maximum m, or maximum m, and this is creating the second table. The name of the second table is that, and the primary key of the second table is that. Or if you have at most 3, then you can put them all into the 3 here. You can put them all in 1 like that. Now, the trouble with something like this is it's harder to search for. Let's say you're trying to search for a particular meal type. If all the flights that serve a particular meal type, I guess, you have to search for all the flights where this one or this one or this one is something. Whereas if it's structured like this, then you only have to search for search this table for meal type, and then that'll point you back to the flight. And so this is a testing on implementing plurals. Here you actually have, and this is often, you often do this, where you have a booking, and a booking, there's got to be a flight number and a passenger number, right? Because otherwise there's not. That's what you're booking. You're booking a passenger on a flight. And in the booking table, you may have the seat number, but you also may want to record changes to the, or to the booking, changes to the booking. So you have this change timestamp field. Now, there can be an unlimited number of changes to a booking. That's why the M is here, or there can be 0 changes to the booking. And so you want to, this is a plural, so you need to have, be able to handle multiple change timestamp records in a change timestamp table for each flight number, comma, passenger. So the name of this new booking table can be booking change timestamp. What is the new flight? What is the primary key of the new table? Well, I guess it would be all 3 of these: the flight number, the passenger number, because that's the primary key of the original table, and then the change timestamp field. And then which column is the foreign key of the new table? Well, it's both flight number and passenger number is a foreign key, or foreign keys. They're actually foreign keys up into the double foreign keys. These together make up the foreign key that connects the booking change timestamp table to booking table, but then they're also connected to the flights table and the passengers table. This here, the main thing I think I get out of this section, as far as doing the quizzes and the activities go, is that every attribute name has a type associated with it. So each attribute has an attribute type included in the attribute name. So here we're starting to talk about these create table statements, and so this one is MySQL compatible, and so this is an attribute. This is like considered an attribute, and it's got an attribute name and it's got an attribute type. Okay, so this char, varchar, char, varchar, those are attribute types. So if you're curious, char means it's going to take 4 spaces, regardless of the size of the airport code. It can't be over 4 spaces. It blank fills if you don't put in 4. Varchar is a maximum of 30 characters, but if it's only 2 characters, it only takes up 2 characters worth of space. Okay, if this were char 30, it would take up 30 characters worth of space, no matter how big the airport name is. Anyway, so here there's an attribute name and a type, and then there's a nice description here of what it is. So that would be in the glossary when you're documenting. Attribute names always include an attribute type. I guess so. Data types are independent of the database system. The answer is they're dependent on the database system. This is false, but really I kind of disagree, because char, varchar, int, those types are universal in all the databases. It's only there's a bunch of, but every database management system has a whole bunch of ones that are unique to it, which can be why people prefer one database management system over another, certain features. And data type depends on attribute cardinality. I don't think it does. It's the attribute itself, not how many are associated with the particular relation or whatever. Implementing cardinality, here again, we're still talking about these attribute type things. So cardinality things are like it's unique, which means it's A unique attribute instance describes at most one entity is unique, at least one, and then instance that's described at least one is a many type thing. Oh, no. And at least one is a not null type thing. And having 0 optional attribute instances each entity instance can have 0 optional attribute instances. That means they have no optional. So that would be null or option. Okay, so that would mean it can be null. And primary key, unique and required are implemented with these keywords. Okay, so unique means at least, no, unique means at most one, not null means at least one, and primary key means exactly one, not null and unique. And again, these are just keywords that go over here, okay, in the attribute name. And these, I don't think that is MySQL compatible, although we can try. When you create table statements from MySQL, what's nice about MySQL, well, what's nice about any database management system is you can take a table and then you can produce the create table statement for that exact table. And I don't ever see primary key appear here next to the name. It's usually down below as a separate attribute, down below the definition of the cities of the fields. But we'll see that. All right, match the, and so understanding that helps you do this, because this is kind of this. It took me this a couple times for me to do this. Match the SQL keyword with the cardinality rule. Okay, so maximum cardinality of 1 would mean unique. It can be none, but if there is one there, it's there's only one of that value. Maximum cardinality of 1. Oh, minimum cardinality of 1 means it cannot be null. It's got to be at least 1. Maximum and minimum cardinality of 1 would be primary key. Now what we're doing here is we're saying what these keywords are out here, okay? And so that's why, like, city name has got nothing after it, and so maximum cardinality of 0. That means it can be blank, it can be null, but there is no. So if there's nothing there, that means that it can be null, and there's no requirement about uniqueness or anything else. So if it can be null and there's no requirement about uniqueness at all, then you don't put any attribute after it, or you don't put any keyword after it. And so that's this one. All right. So here you're trying to fill in what the keyword should be. And the keyword is going to be, one of these things, I guess. So student number would be, I guess, primary key. So it's just testing you what keyword you should put after this to yeah, I don't know. So you can think about and figure out what those are. All right, and this tells you what you should, how you take this section and summarize the steps, the step activities to when you're actually implementing tables that are attributes. All right, so we can do these. Okay, let's do one of these. Let's do a couple of these. Implementing attributes. Okay, so which properties apply to each attribute? Okay, to the account ID 111, unique and required. Account name 111. I guess it's this. Can two things have exactly the same timestamp? I suppose. So I don't think it's.
Oh, for the creation timestamp, I just got the same one. It says that it's not plural, it's just required.
Oh.
It says the M has to be to the right of the dash to be plural.
Oh. Okay, so to the left of the dash just means
Means not
okay.
Unique or
Okay, let's see. Yeah, you're right. Is that what you said, right? Yeah.
Yeah. I thought that was kind of confusing though for the creation timestamp.
What does the M to the left of the dash mean? Oh, that just means that multiple accounts can be created at the same time. Yeah, so this is not intended to be a plural thing, but because there's just a creation. So you create a new account, there's a creation timestamp there, and it never changes. It's not like you're updating like the above example. And you can create a whole bunch of accounts at exactly the same time, but each account is only going to have one creation time, right? Yeah.
Okay.
So that means it's not plural. Yeah. Okay. Right. Okay. So that makes sense. So if you have this account table, there's nothing plural about the creation timestamp.
Okay.
Yeah.
Okay, that makes sense now. Yeah. Okay.
Let's try one more. Okay, it's 11:04. We have one. Oh, okay. Yeah, the next section is short. Book format. Book format is hardcover, paperback, or audiobook. Each book may be offered in multiple formats. So book format is a plural attribute. Implement book format in the book format table, separate from the book table. Okay, so which columns are included in the book format table? And the primary key and the foreign key. Okay, so what is this? Is there? What is? Oh. Okay, first of all, the whole table itself. You have a book format table. Okay, the book format table just says 3 records in it.
I think so.
Yeah, okay, so I guess they would have a book. I guess the table just has that. I guess so. And what's the primary?
Book code?
Isn't the book book code is associated with MM. So yeah, okay, so we're talking about a Oh, okay, a book cannot. Okay, so so I guess we're talking about a table that's got the book code.
Oh, I got the same one, so I just filled it out, but I mean, I got it wrong, but so I guess, so foreign key, the
Would
only
be
foreign key would be book code, they said.
okay. And the prime. Okay, so this other table should have a book code and a book format in it. Would that be right? I think.
Right. So for primary, then we put book code, book format. It's
Right.
just the way they have the question formatted is weird.
Yeah. Yeah. And the table itself is gonna be both those,
Book
right?
code and book format.
Right.
Yeah.
Right. And what's gonna be left in the book table itself is just gonna be, well, okay. So and then what? Okay, I guess there doesn't need to be anything in the book table
Yeah.
regarding book format. So that gets taken out, I guess. Well, okay, so it is
I think that's
it.
right. It.
Let's see. Okay, yeah. All right, let's do the next one. Okay, the account entity contains the following attributes: account ID, account name, and creation time stamp. Wait, didn't we just do this? Oh, well, it's the same scenario, I guess. Okay, so the glossary contains the following attribute type descriptions. ID is an integer number, name is a combination of, yeah, okay, up to 15. And the timestamp is that MySQL time format, SQL time format. Select the data type for each column of the account table. Okay, so this would be data type, int. Account name would be up to, this works. And timestamp would be date time. Well, that seems easy. All right, let's do the last one. Complete the create table statement based on the following entity. So this should be, I guess, primary key. And this is, I don't know, not null. And because it's got to have a course code. Course name, yeah, it's got to have a course name too. Oh. Do I say unique or something?
I was thinking that.
And this can be not null.
Okay, yeah, I didn't get that far because I kept getting the second one wrong because that weird formatting.
Oh. All right.
Okay.
All right. Good. Let's go to normalization here.
Okay.
Okay. So in normalization, this is you should read through this, and it gives a good description of a pretty complete approach to when normalizing your table to reduce most or all of the redundancy. And then it goes on to say that you may not always want to have tables in this most highest normal form, because it may be convenient for you to have it in a lesser normal form, like third or second or first, actually, because it's easier to read. It's easier for humans to read. And it also can be easier for the database search engines to actually complete the search. That's kind of questionable because it doesn't take the database management system very long to do the joins to put the table back into a denormalized form on the fly to do your searches. But I guess it can help a little bit. So so here we have like voice cod. Let's see, editing. So here, column. So when we normalize, that's the process of eliminating redundancy by decomposing a table into two or more tables that are in a higher normal form. And so, and then it goes on and say fourth and fifth are complex, so we have limited practical value. And I've said before that in the assignment, there's a couple of fourth and fifth normal form examples that might lead you to believe that it's maybe the practical value is not all that limited. But anyway, it's after you work with databases a while, you can just, you aren't thinking about normal forms, you're just looking and noticing, oh yeah, these can be redundant, or this should be in a separate table, because you understand what the data represents. So in voice cod normal form, if column A depends on column B, then B must be unique. Okay, so if you want to think of column A depends on column B, it's like the city depends on zip code. Okay, because a zip code can determine what the city is. There's no zip code that is shared by two cities. There are lots of a city can have lots of zip codes, but if you know the zip code, you know what the city is. If you know the city, you may not know what the zip code is. If that city has multiple zip codes, it's possible the city just has one zip code, in which case you would, but you would know, but we're not talking about that. So city depends on zip code when each zip code value is related to at most one city. So each zip code value is related to at most one city. And so for it to be in voice cod normal form, if city depends on zip code, then zip code must be unique. Okay, and so that's why in a table of people, and if the table includes their name and their address and their city and their state and their zip code, that is not in voice cod, because the zip code field would not be unique. You could have a bunch of people living in Hawaii or whatever in a zip code, and so it's not unique. So normalizing to voice cod normal form involves first listing all the unique columns, and then taking all the non-unique columns and the non-unique columns are either external to all unique columns or contained within a composite of the unique column. You identify those, and then you eliminate the dependencies on non-unique columns by removing them from the original table and creating a second table. And so what you would do for city and zip code is you would pull those out into a separate table that has zip code as the primary key and city as an attribute. And then in the names and addresses table, you only have the zip code. You don't have the city. You only have the zip code. So that, in fact, is an example of when you want to produce a table of names and addresses for somebody, you might not want it in voice cod normal form, because you might want to know right away what the city is. And so you would denormalize it, and actually the example that I was using had to do with third normal form, not voice cod. Voice cod is a little bit different, but it's the same idea. You still go through these. Voice cod deals with non-unique columns. Well, anyway, that's a detail. So here in talks about voice cod's original paper, the term normalization, and after a while we began to use the term normalization as achieving higher normal forms, whereas his original paper just talked about it going from nothing, from not being normalized, where a cell might have multiple values, or there's columns with the same names and duplicate rows and so on, and achieving first normal form is really what Cod considered as normalization. But anyway, so this represents an activity. I mean, a process of normalizing. We have registration codes, student ID. This student ID, course number, and term is a composite unique. These are courses over here. They don't really depend on anything, although you could say that it's between credit courses there could be some sort. No, I guess not. You would take this composite unique from the, see, this is course number and course name and credit goes into one table, and let's see what this does. Time is 15. That's unique column. This is a composite unique column, and course name and credits depend on course number. Redundancy is eliminated by removing the course name and credit, and so that's and then a course number, course name, credit are put in a new table, and all dependencies in the course table are on a unique column. All dependencies in the course table are on a unique column. So this is a unique column, and so they all depend exactly on this. And all right, we done? I guess so. Okay. So this goes through exercises of how to normalize because of these dependencies, and then this talks about denormalizing, to bring something back, and you should store stuff like we show up here, but when presented, we may want to denormalize it, or in fact, and then put this back in a table, which could be the finished booking table for a particular flight, for example, or whatever, a particular day, and then searching for bookings on a particular day can be just on a single table like that. And this talks about designing, and you can do this one. I'd like to, in the last 10 minutes, I'd like to start the assignment here. So the assignment is the second one here, normalization by projection. And so you can read the, there's a video somewhere. Yeah, here's a video. So many of you may have gone through the video already, but in case you haven't, let's try to do this. So I'm going to go to my grading assistant here. Let me just get rid of some of this stuff. I'm going to open up the grading assistant, and here it is. And so I'm going to use this, and so I'm doing this one here. Except for I think I already did it. let me see what's up. Oh, okay, so I'm gonna go to my cPanel and log in. And I'm gonna go look and see what I have a database there now for assignment, this assignment, I believe. Do I have oh. Guess I can do that. So let's go to all right, I suppose I'm gonna delete I'll delete the what's there and recreate it from scratch. I can do that. Create an I don't know. I think there's a bug in the grader. I recall now, I think there's a bug in the grader having to do with detecting whether or not you have created your view. So I'm going to create the view how it should be, and I think the auto grader, if I recall, I can't remember if I fixed it or not, but I'll find out by the end of this video. All right, so I have a table here, and this is the supplier parts table that we looked at in the first assignment. So if you quickly look at the first assignment, it's actually here the table's all decomposed already. We have a suppliers table, and there's 5 suppliers, and there's a supplier number, that's the primary key. And then we have got a parts table with these parts, attributes, and this is the primary key. And then this is supposed to represent parts in transit, let's say shipping. A supplier ships parts, and a supplier ships ships 300 of these parts. So Smith from London is currently shipping 300 red nuts to London, or from London. It's a but in this database, keep in mind this city refers to where Smith is, and this city refers to where the parts are. Okay, so we have we happen to have two tables here with columns with the same name, and they mean different things. Okay, so that just that's a note. That means that you can't do natural joins on this table and this table, because it's going to think that this city means the same as this city. But anyway, this is what the first one is supposed to break down to. So let's go back here. And here we have a denormalized version where we have this is suppliers who are shipping parts, and this is the number of parts, and this is the part, and this is the color of the part, the weight of the part, where the part city is, and by the way, I'm putting a P there for part city, and this is S for supplier city and London. So you may notice that there's actually one record for, let me just go back to, there's one record in that database for every record here, because so it happens to be the same number, and so what our first task is to, question 1 is to decompose this table into the set of tables that were in the assignment 1, and here it's instructions on how to do it. Suppliers each have an ID and a name and a status and a city. Is that what I name them? Oh, I guess I do name them. Each part has these attributes, and suppliers are currently shipping these quantity of parts. Okay, this quantity. And so first we want to create a database, name it that. Then we want to import the above table into into this database. Choose appropriate field types. These are attribute types. And then make sure you specify the primary key correctly, and then decompose them into a set of BC and F tables in there, and name them this. the suppliers table, the parts table, and the supplier parts table, and make sure you specify the keys and indexes correctly. Do I say, I don't think I'm that picky about the foreign key constraints. Actually, I might be. So this is a step-by-step. And let's see, how do I do it here? I actually create a .csv file. Open up Excel. Here I tell you what the types are. And then here I tell you how to create each table. This creates the S table, this creates the P table, and this creates the SP table from a selection of the original. Creates a P table from a selection of the original, and it creates the SP table as a selection from the original. And then here I say create the foreign key constraints, and I don't think I'm very picky about those. Okay, so this gives you a detailed instructions on how to do this one. And for question 2, it's similar. Okay, in question 1, this is the primary key of the S table. This is the primary key of the P table, and this plus this is the primary key of the quantities table. The quantities table just says this and this and this as columns. The S table has these 4 as columns, and the P table has these 5 as columns. For this one, this is employees and projects and hours applied to projects. So we have employees, we've got employees, and we've got projects, and then we've got employee hours that are applied to an employee ID and a project ID. Okay, so I want you to decompose it, and I actually want you to decompose it . Okay, I actually want you to have this and this in a separate table also. You see, I ask you to make 4 tables: an employee table, a project table, an employee hours table, and a zip city table. For this one, this happens to be a 4th normal form type of table of assignment, because in this scenario we have it's a the scenario is it's a restaurant, and they've designed certain meals, just with meals where you order like the meal of the day or something, and so they create a menu each day with these meals, and they will only pair certain main dishes with certain side dishes with certain wines. Okay, and there's some rules underneath this for the pairing of salmon with what type of side dish, and the pairing of salmon with what type of wine. And we see here from this table, oh, by the way, this table is in BCNF. This table is in BCNF because for this table, all 3 of these make up the primary key. Okay, these rows are unique, and so the primary key is all 3 of these together. And so if you have a table and all of the columns make up the primary key, a huge composite primary key, then it's in BCNF, because there are no non-key attributes that determine a key attribute. You know, for it not to be in BCNF, you can't have that, and there's obviously not that here, so this is in BCNF, but there's still redundancy. And that's because this is a multi-value dependency. Salmon steak determines a side dish of either mashed potato or white rice, but nothing else. Okay, not baked potato, not not baked potato, I guess. So those are the three. And then beefsteak determines the side dish. With the beefsteak, you can have baked potato, you can have mashed potato, but you cannot have white rice. So it's a multi-value dependency. And then for wine, it's the same thing. In this particular one, the rule is white wine with fish, red wine with beef. So salmon steak determines Pinot Grigio or Chardonnay, and beefsteak, you can have Pinot Noir or Cabernet Sauvignon, which are reds, but you cannot have Chardonnay or Pinot Grigio because those are whites. And so you can see there's redundancy here, but we're still in BCNF. So what we need to do is we need to create two tables from here, and one table is going to have main dish and side dish, and the second table is going to have main dish and wine. Got these two tables, and then to recreate the and so I'll get into this. I may cover this assignment in again next time, because here we start to get into the distinction of why we needed to be in fourth normal form. But to test the validity of an entry, to test the validity of a meal. Okay, you pick a main dish, you pick a side dish, you pick a wine. You have to test whether or not that's a valid meal according to our rules. So you search for your main dish, side dish, wine. You search for that in a table that is the join of the natural join of these two tables. And if it's in the natural join of those two tables, then it's a valid meal. If it's not in the natural join of those two tables, then it's not a valid meal. So that's this one. And this is also a similar kind of problem where you have the course determines the textbook, and it's a multi-valued dependency because a course requires two textbooks. This course requires ICS 101 requires two textbooks. ICS 129 and 149 determine a textbook. 227 determines a textbook, and this 250 determines a textbook. So there's certain books. If you have the course there's certain textbooks, multi-valued. Also, the instructors can only teach certain courses. For ICS 101, this guy can teach it, and this guy can teach it, and actually, maybe everybody can teach ICS 101. But then for these two, which happen to be database classes, only this guy can teach that. And so you have this other multi-valued dependency, course determining instructor. And so you need to decompose it into two tables, and this tells you how to do that. So that's these assignments. And I think it's the end now, and I got to go someplace. So I think I may have one more shortened lesson. I'll cram that in because it might be interesting for you to see how to do these. Although you can just watch the videos, and you can get a long way there. I will check to see how you all are doing on this assignment. I can look at my control panel, and if most of you are finished already, I won't bother going over this assignment. But if most of you are not finished, then I can take about 10 minutes because it's really fast. If you follow these instructions here carefully, you see that how easy it is.
Okay.
Okay.
Okay. Thank you.
All right. So I'll see you next time. That's it for this week.
Yeah. Okay. Thank you so much.
Thanks for watching.
Okay. Take care. Thanks.